So for our first full process of the hypothesis test, let's take a look at this following problem. In 1997, 46% of Americans said they did not trust the media when it comes to reporting the news fully, accurately, and fairly. In a 2007 poll of 1,010 adults nationwide, 525 stated they did not trust the media. At the alpha of 0.05 level significance, is there evidence to support the claim that the percentage of Americans that do not trust the media to report fully and accurately has increased since 1997? All right, so throughout there we can see we have information about percentages or even the so many out of so many. So this is definitely a question of proportion. So recall, before we jump into the test, we do need to check that we would be allowed to use the normal distribution to approximate or to model this. So very first thing we do is we check. Now that involves using the value for p of 0.46. So we have the n, p, 1 minus p check. So the n of 1,010 adults that we have here times the 0.46 and the complement of 0.46, so 0.54. And that's coming out, oops, if I type the right number, it would help. Coming out to well over 250, 250.9, which is definitely at least 10. So we're good there. So now we will start with the hypotheses themselves, stating the hypotheses, the null and the alternative. So like I stated, we're definitely dealing with proportion here. And the originally believed to be true value is that the proportion was 0.46. Our statement that we're trying to support is that it is increased, so greater than 0.46. Okay? That's really it. That's all we do with the stating of the hypotheses. Now, let's take a look at what our test statistic will be. So remember, that comes from, if I can spell it, statistic. So remember, that comes from the sample and comes from our formula for what we call Z naught of p hat minus p naught over the whole square root of p naught 1 minus p naught over n. So for p hat, we do have to take a moment and calculate that because they did not just directly give it to us. So p hat is that 525 out of 1,010. And we'll take the 4 places for some accuracy, 5198. So that's our value for p hat. Now p naught, remember, is the number that it's originally believed to be, so 0.46. And then same thing for 0.46 times 0.54 over our sample size of 1,010. All right, so let's make sure we can get that typed into the calculator correctly. I'm going to show you real quickly here. This is what it looks like on my calculator. You really don't need to overuse parentheses there in the denominator if you don't want to, given that order of operations would take care of the computing that correctly. And so that comes out to be 3.813. We'll take that 3 places because remember, this is a z-score really. And so that is our test statistic. I'll abbreviate that TS just as a reminder. So that's our test statistic. Now we want to also find our critical value and region, critical region. Now remember, that always comes from your alternative. The alternative's inequality symbol, greater than, tells you that we're dealing with a right-tailed test. And what also we know about this picture is that our value of alpha of 0.05, since alpha equals 0.05, that's the area of that tail. And once you've got that picture labeled in that way, you can jump right to using inverse norm. Now in this case, if this is 0.5, to its left is 0.95. So we need inverse norm of 0.95, which is 1.645. And so that there, we would use the notation of Z alpha or label it the critical value that we just found there. So we've used our hypotheses, we've found our test statistic from our sample, our critical value and critical region from alpha and the type of test that we're dealing with. So the next quick thing, this does not take long, this is the decision step. This is where you actually make the statement about the null. Well, I'm going to draw a really quick picture again, just recreating that picture up there, where we know the boundary of this critical region is that 1.645. But then the question is, where does this value, 3.813, fall? Well, we know with a normal curve, we're centered here at 0, so 3.8 definitely falls to the right somewhere of 1.64. So wherever it falls, 3.813, and in fact, if you think about what we know about the normal curve, right? We know that something that's 3.813 for a z-score is 3.8 standard deviations away. So we actually talked about how with a normal curve, normally it's pretty much flattened out at the plus and minus 3. So this actually should be even further out here. Doesn't matter. All that matters is it's to the right of this boundary. It's in this tail. It's in that critical region, or what I mentioned can also be called the rejection region. So since our test statistic is in the rejection region, right? Since the z naught is greater than the z alpha in this case, right? Bigger, larger, we're going to reject the null hypothesis, right? Our test statistic from our sample is in that tail, so we reject. That's how that goes. And then from there, we simply need to write our conclusion, which is the nice long sentence that puts us back into words. And so we said we always start with the level of significance. So at a level of significance of 0.05, now we are saying that we can reject the null. If we're rejecting the null, that means we had evidence to support the alternative, so we can say there is sufficient evidence to support the claim that, and now we just take that claim, that alternative, and put it back in the words, that the population proportion of Americans that trust the media, I'll abbreviate this a bit here, I'm not going to put all the details there, but that trust the media is greater than 0.46.